Okay, hello, Algebra 2. Unfortunately, I'm still waiting for some tests to come back, so this class will be delivered from the Marblehead campus of St. Mary's, otherwise known as my home office. All right, so we're going to work on solving nonlinear systems, and we're going to continue, or we're going to start working on how to solve them by substitution, okay? So before we get into nonlinear systems, let's just review if I gave you a linear system, right, two lines, how you would solve a linear system by substitution. This is something we did back in the fall, and I think we'll go through an example because the process is pretty similar for a nonlinear system. So here's a linear system: negative x plus y equals negative 4, 4x minus y equals 10. Okay, we know that's a linear system because each of the variables is raised to the power of 1, which means that we could write each of those in slope-intercept form, which means that it's going to graph a line. And so we have a linear system, two equations that produce lines graphically. All right. So the first step that we would do here is we look at this and we say we need to solve one of these equations for one variable. We need to isolate one variable. So I'm going to take the first one, okay, and I'm going to turn negative x plus y equals negative 4, and I'm going to solve that for y. Okay, all I have to do is add x on both sides to solve it for y. So this becomes y equals x minus 4, okay? All I did was add x to both sides. Now I have isolated one of the variables, right? So y equals x minus 4. Now I'm going to work with the second equation. All right. Now, wherever in the second equation, wherever I have a y, I can replace it with x minus 4. This is going to allow me to turn this two-variable expression into a one-variable expression, which allows me to solve for that variable. Okay. So 4x minus y equals 10 turns into 4x minus, now instead of y, I'm going to use x minus 4 because y is equal to x minus 4. That's the substitution. Put my parentheses in, x minus 4 equals 10. Okay? All I did was substitute in x minus 4 for y. Now we just clean it up a little bit from an algebraic standpoint. We have a negative 1 here that we have to distribute. So this turns into 4x minus x. A negative times a negative 4 is positive 4 plus 4 equals 10. Combine like terms, 4x minus x is 3x. Subtract 4 from both sides. 3x equals 6. So therefore, x equals 2. Okay? Once we know x equals 2, we can go back to the initial system, the original system, and we can pick either one of these and plug in 2 for x and find y. So let's use the first one, negative x plus y equals negative 4, right? We're just going to stick 2 in for x, okay? So negative 2 plus y equals negative 4, okay? Negative 2 plus y equals negative 4, so we're going to add 2 to both sides, right? So y, I'm just going to move it up here, y would equal negative 2. So our solution to this system, our solution would be the coordinate point 2, negative 2, okay? Now that's an example of using substitution on a linear system, okay? We've done that plenty. We did that lots in the fall, back in 2020, okay? And basically, you're just solving for one of the variables, right? That's the first step. Then plugging that in into the second equation, solving for either x or y, and then using that, putting it back in, and solving for the other variables. Pretty straightforward stuff, okay? And if you need to refresh your memory on solving linear systems by substitution, you should go back and check your notes from the fall, okay? Okay, so let's look at an example of a nonlinear system. So let's say that I gave you x squared plus x minus y equals negative 1, and x plus y equals 4. All right, we know this is a nonlinear system because we have a clear quadratic term, right? This is going to produce a parabola, and we have a clear linear term that's going to produce a line. So we have a combination of a quadratic, a nonlinear expression, and a linear expression, okay? We said that nonlinear systems don't have to be both nonlinear. They could be nonlinear. They could be, one of them could be nonlinear, and one of them could be linear, okay? That makes it nonlinear overall, okay? So the first thing we're going to do is we're going to solve this one, the second one, this easy, the linear one. Let's solve it for y. So in order to solve this for y, we're going to subtract x from both sides, right? So x plus y equals 4. We subtract y from both sides, right? That goes away. This is going to turn into x equals negative y plus 4, okay? All right. Now, you could also solve this for y, right? We could do it both ways. We could do x plus y equals 4. We could solve for y by subtracting x on both sides, right? In that case, we would get y equals negative x plus 4. Either one is fine because we're going to use that for substitution purposes. In fact, I'm going to use this one because we only have one y term. If we substitute for x, we have to substitute for both these, right? Okay, so I'm going to actually use this one upon further inspection, all right? So that's the first step, is to solve the linear expression for one of the variables. Here we did both for the x and for the y, okay? We're going to use this one. Now we have to move to the quadratic, okay? So our quadratic is x squared plus x minus y equals negative 1, right? Here we're going to substitute in this negative x plus 4 for our y. That's going to give us an expression with just one variable that we can solve for that variable, okay? So when we do that, we're going to get x squared plus x minus, now we substitute in for y. Y equals negative x plus 4, right? So put my parentheses in, negative x plus 4 equals negative 1. Okay, we'd have to clean this up a little bit, right? So we have a negative 1 here that we have to distribute. X squared plus x, a negative 1 times a negative is a positive, plus x, a negative times a positive is a negative, minus 4 equals negative 1. Let's combine these like terms. X squared plus 2x minus 4 equals negative 1. Okay? All right. Now, let's put this in standard form, okay? Which means you have to add 1 to both sides, all right? If we add 1 to both sides, we get x squared plus 2x, add 1 to both sides, minus 3, because negative 4 plus 1 is negative 3, equals negative 1 plus 1 is 0. Okay, so now we have something in standard form set to 0, okay? So the question we have to ask ourselves now is, can we factor that? Or do we have to use completing the squares? Because we're going to solve for x, all right? We have to solve for x. So the first question we should ask ourselves, again, is, can we easily factor that? And that's another way of asking the same question is, are there two numbers that multiply together to give negative 3, but add together, negative 3, but add together to give positive 2? Well, yeah, I think so, right? Positive 3 and a negative 1, right? Positive 3 times negative 1 is negative 3. 3 minus 1 is 2. So, our x squared plus 2x minus 3 equals 0 can be factored into x plus 3 times x minus 1 equals 0. All right, this one we don't need to use completing the square. We don't need to use the quadratic formula. We can just factor it, okay? So that'd be the first question that you ask yourself, right? Now we solve for x, right? So x plus 3 equals 0. So that means one of our solutions is x minus 3. X equals minus 3. X minus 1 equals 0. That means our other solution is x equals 1, okay? So we've got two solutions to this quadratic, two real solutions to this quadratic, okay? All right, what do we do with these? What do we do with these? Well, we have to use these and put them back into, substitute them back into one of our initial expressions, right? Take the linear expression. It's a lot easier, right? So we have to basically run two cases. One where x is equal to -3, and one where x is equal to 1. So our linear expression is x plus y equals 4, right? X plus y equals 4. And in this case, x is going to equal -3, so we substitute that in. -3 plus y equals 4. In order to get rid of this, we have to add 3 to both sides, right? So y equals 7. So one of our solutions, we're going to have two solutions. One of our solutions is -3, comma 7. Okay, that's one of our solutions. But we also have this solution, right? So x is 1, so 1 plus y equals 4. Subtract 1 from both sides. That goes away. Y equals 3. So another one of our solutions is 1, comma 3. Okay? So we have two solutions here. Okay? We have two solutions. Our two solutions are -3, 7 and 1, comma 3. So this system, right? This quadratic, it's a smiley face, right? And this line, it's got a negative slope, because if we subtract that, y equals -x plus 4, right? This system is going to have 2 points of intersection, right? It's going to probably look something like, let's see, it's going to look something like that, okay? And we're going to have, 2 points of intersection, like that and like that, all right? This one is going to be -3, comma 7, right? And this one's going to be 1, comma 3, okay? And that's the process by using substitution to solve a non-linear system, okay? I'm going to stop here. Make sure you watch this and take notes. Go through the example. I'm going to post probably another video going through another example.